Math 83, Unit 4, Lesson 3. We're going to simplify rational expressions. And we always want to make sure we factor first before we simplify. Well, in number 1, we can't really factor out anything in the monomial that's in the numerator or denominator. But what we can do is go ahead and expand it out. So this means 2 times x times x times x times y. And our denominator, our 6, is 2 times 3. X squared is x times x. And y to the 5th is y times y times y times y times y. Now we can divide out common factors. We can divide out a 2 in the numerator and denominator. We can divide out an x times an x. There's an x times an x down here we can take out. And we can take out a y from the numerator and denominator. So we're left with an x here in the numerator, and then a 3 y to the 4th in the denominator. In number 2, when we expand it out, we can rewrite it as negative 7p times p, and then q times q times q times q times q. In our denominator, we can break apart the negative 14 to be negative 7 times 2. And then p to the 6 we'll write as p times p times p times p times p times p. Dividing out common factors, we can divide out a negative 7. We can divide out a p times a p. And we don't have any q's in the denominator, so there's nothing to divide out. So we're left with q to the 5th in the numerator, a 2, and then a p to the 4th in the denominator. In number 3, they've already factored this one out for us. We can divide out an x from the numerator and denominator, and also the x plus 7 can be divided out because there's one in the numerator and also one in the denominator. So this simplifies to just be 2/7. In number 6, we have an x minus 3 in the numerator and in the denominator, so we can divide that out. 6 goes into itself once and into 12 twice. So we're left with x plus 5 in the numerator, and then we're left with this 2, and then there's an x, so 2x in the denominator. It is tempting to want to simplify the x's here, but we can't because this means x plus 5, and we can only divide out common factors, and that's things that are being multiplied together. And this is a sum up here, so this cannot be simplified any further. So the ones in the first 4 were already factored for us or couldn't factor, but now we have to remember to factor first. So when we look at our numerator, we can pull out the greatest common factor, which is 8, and we can rewrite this as 8 times y minus 1. And then we'll just have 8 in the denominator. And now that we have an 8 in the numerator and 8 in the denominator, we can divide them both out, and we're left with y minus 1. In number 6, when we factor first, we can pull out a 2 from our numerator, and we get x minus 5 left. Nothing to factor in the denominator, so I'll just rewrite it as x minus 5. Now all this goes together, our x minus 5. So we can divide out an x minus 5 from our numerator and from our denominator. So the answer is 2. In number 7, we're going to factor the numerator first. We can pull out the greatest common factor of 3, and we'd be left with x squared plus y. In the denominator, we can pull out the greatest common factor again of 3, and we're left with 5x squared plus 3y. So we have a common factor of 3 here that we can divide out, and we rewrite what's left, x squared plus y over 5x squared plus 3y. And even though it's tempting to want to cross out those x squares and the y, we can't do that because this is a sum here in the middle, and you can only divide out common factors. So that's the most we can do. So this is in simplified form. In number 8, we can factor only the denominator, so we're going to leave the numerator alone. And then denominator, we can factor out a 3, and we're left with y plus 2. And when we want to divide out the y plus 2's, this y plus 2 goes all together. When we divide it out of the numerator and denominator, y plus 2 divided by y plus 2 is 1. And we're left with 1/3. In number 9, we can pull out the greatest common factor in the numerator, and that's going to be a 5, and we're left with p plus 3. Now, our denominator is a trinomial where a is 1. So here we can factor with the reverse FOIL method. We have p times p is p squared. We're looking for two numbers that multiply to be negative 15 and add to be negative 2. And that's going to be a plus 3 and a minus 5. So 3 times negative 5 is negative 15, and 3 plus negative 5 gives us our negative 2 here in the middle. So the common factor we can divide out is p plus 3, and we're left with 5 over p minus 5. In number 10, we can pull out the greatest common factor in the numerator, which is 3, and we're left with t minus 3. Our denominator is a difference of squares. So we can rewrite this as t times t is t squared, two numbers that multiply together to be negative 9, but add together to be 0, because we don't have a middle term. Well, those are going to be a negative 3 and a 3 that give me that. So we can divide out an x minus 3, and we're left with 3 over t plus 3. In number 11, we have a trinomial where a is 1 in the numerator, and also a trinomial in the denominator where a is 1. So we can factor the numerator and the denominator with our two sets of parentheses. And we know that x times x is s squared, so two numbers that multiply together to be negative 10 and add to be 3 are going to be plus 5 and minus 2. And then two numbers that multiply to be 16 and add to be negative 10 are going to be minus 8 and a minus 2, because negative 8 times negative 2 is positive 16, and negative 2 plus negative 8 is going to be our negative 10 here in the middle. So the common factor is x minus 2 that we can divide out of both numerator and denominator, and we're left with x plus 5 over x minus 8. Again, those x's cannot be canceled because this is a sum and a difference in the numerator and denominator. They're not products, and you can only divide out common factors. Do number 12 on your own, pause the video, and come back and check your answer. Here is the answer to number 12. We have x plus 9 over x plus 10. So in number 13, we're going to multiply this rational expression, and then we're going to write our answer in simplest form. Well, these are just like multiplying fractions when we multiply rational expressions, where we can divide out common factors that are diagonal of each other. So 3 goes into itself once and into 9 3 times, and then 8 goes into itself once and into 45 times. And then we can multiply numerator times numerator, denominator times denominator. So 1 times 1 is 1, and 3 times 5 is 15. In number 14, we can reduce diagonally by dividing out a 2 out of both of these. And then when we multiply straight across, we have a 5x times a y is going to be a 5xy, and then a 1 times 3 is going to be 3. And that can't simplify anymore. In number 15, I'm going to rewrite this x to the third as x times x times x. And when I divide out something diagonally, I can take an x out of this numerator and an x out of this denominator. So when we multiply across, we're left with 2 over 3, and then we have an x squared. Number 16, we can rewrite y cubed here as y times y times y. And when we reduce diagonally, we can take one of these y's out and one of these y's out. And then 8 divided by 2 is 4, and 10 divided by 2 is 5. So when we multiply across, we have a negative times a positive is going to be a negative, and then we have a negative 5. In the denominator, we have a 4y squared. When we divide fractions, we keep the first fraction the same. We change to multiplication, and we flip the second fraction. So what we're doing here is we're multiplying by the reciprocal. Now we use the same rules for multiplying fractions. We can divide out common factors diagonally. 9 goes into itself once and into 36 4 times. 2 goes into itself once and into 6 3 times. 3 times 1 is 3, and 4 times 1 is 4. In number 18, we're going to keep the first fraction the same, and I'm going to go ahead and expand out that x to the fourth to be x times x times x times x. We're going to multiply by the reciprocal. So the 7x squared comes up here, and this becomes 7 times x when I expand it out over 2. We're going to reduce diagonally. We can take out an x and an x from here and here. And then our numbers, 2 goes into itself once and into 6 3 times. Now when we multiply across, we have 3 times 7 is 21. And then we have this x squared left down here. So 21 over x squared. Number 19, we're going to keep the first fraction the same. I'm also going to expand out p squared to be p times p. Put that over 5, multiply by the reciprocal, so the 10 comes up top, and then I have a p times p down here. We can divide out a p and a p from the numerator and denominator here, and then 5 goes into itself once and into 10 twice. Multiplying across, we have a 2 and then a 1 down here, so we just have a final answer of 2. In 20, we're going to rewrite y squared as y times y, and then y plus 9 cannot be factored, so we're going to leave that as y plus 9. We're going to multiply by the reciprocal, and when I bring 7y plus 63 up to the numerator, I can see that I can factor out the greatest common factor. So I'm going to take a 7 out of each term and rewrite this as 7 times y plus 9 all over y to the fifth would be y times y times y times y times y. So let's see what divides out. We have a y and a y here in the numerator. It divides out with a y and a y in the denominator. Our x plus 9s, there's 1 here in the numerator, and all of this divides out. And it looks like that's it. So when we multiply across, we have 7 times 1 would just be 7, and we're left with these y's right here, so that's y to the third.